Hello, welcome to Maths with EJD. Now, in this video, I thought to write a Python code to show you what I demonstrate, the worked example in the previous video on how to use Markov chain to predict whether it's going to be rainy or sunny, depending on the situation you have. So this is the Python code right here. And I'll just try to unpack that and look at some scenarios as we bring this to a close. Okay, so of course, I don't know if you're not used to Python already. We have things in Python called library. So we are using NumPy in this case. NumPy is numerical Python, so it's good for numerical stuff, especially when you're dealing with arrays, matrices, and things like that. Okay, all right. So uh, in our of course, if you don't know the context for this, you can check the previous video on my channel on the playlist for probability, that's Markov chain, a worked example for weather prediction and Markov chain. So this is the code to explain the idea that as you keep on iterating, with your current state and the transition matrix, it gets to a point that the system tends to stabilize. And that is what exactly I want to explain using this code. For you to get to that point of stabilization, there's going to be, if you want to do that manually, it will take a lot of effort. And that's why computing has really helped with so many of these things. Okay. So, okay, I think let me put line number so I can easily refer to the lines. Okay. So in line one, I imported the NumPy library as an alias called NP. So in line three, now that I have a comment there so we are defining the transition matrix. So whatever transition matrix you have, depending on the situation you have. So in the question we have, right, the transition matrix is that, the probability that if it is sunny, it is going to remain sunny tomorrow is 80%, that's 0.8. If it is sunny today and so the probability that it will be raining tomorrow is 0.2. Then if it is raining today, the probability that it will now be sunny tomorrow is 0.4. Then if it is raining today, the probability that it will be sunny tomorrow is 0.6. If it is raining today, the probability that it will remain rainy tomorrow rather is 60%, which is 0.6. So that's what we have in this transition matrix. So any scenario you have, you can now use your own code. You just need to change the transition matrix based on the situation you have in your case. So the next thing is so we are defining the initial state. Define the initial state. It is sunny with 100% probability and it is raining with 0%. So that means your X naught in line 8 is array, which is one, probability of one. That's the highest probability you can have, 100%, and zero, that you are sure it is not going to rain. Of course, you can see NP array. NP array means you're calling a function called array from the NumPy, not from the NumPy library. Okay, so uh, so you see these are the basic two things. Now you have the state and you have the transition matrix. So every other thing is just some Python stuff. Okay, so first of all, in line 10, right, we are defining the function to iterate and show the probabilities over time. So so the function is defined. So use DEF to define it to define functions, right? So and here we are talking about weather forecast convergence. So T, of course, is your transition matrix. X naught is the initial state. Then how many iterations do you want to do? So here you can always come back here to change to maybe 50 iterations, 100 iterations, and things like that. And your tolerance limit, you want it to be 10 raised per minus 6. That's 0.0000001, So the higher your tolerance, the more accurate your result is going to be. So in line 13 now, you set the initial state vector, which is current state, which is our X naught here, to be 1, 0. And then if line 15 says print header for readability. So here we just want to show the number of iterations, and then we want to show if it is sunny and rainy and all that. And then we print all the results that we have like that. Okay, so now in line 19, iterate and multiply the state vector by the transition matrix. So of course, we keep multiplying the state vector by the transition matrix to get the next state. That's what we did in the previous video where we're doing the maths, right? So now, so for I in range 1, iteration plus 1. So starting from first iteration to so it's more like this is state 1. The next, so iteration plus 1 is the next state, right? So the next state is np dot current state t. So it means you're multiplying the current state by the transition matrix. That's what line 21 is about. And in 23 now, you want to find print probabilities for current iteration. So once you get the probability for current iteration, then you print the results. That's what line 24 is doing. Line 26 is to check for convergence by comparing the current and next state. So if you compare the current state and the next state, and you compare it with the tolerance, then it will tell us if the value has converged or not. Of course, for convergence to be reached, right? So you have the comparison between the two states has to be either less than or equal to the tolerance we have set for ourselves. And if you want more iterations, right, you can set more iterations there, and you can also increase your tolerance. So the smaller the tolerance value, the more accurate your results will be, or something like that. So, and once convergence is achieved, the system outputs the result. So here now, uh, so here, we have this, should I say, is it recursive that I should call it now? So you have this iteration thing going on. So update current state for the next iteration. So current state will now be next state. So what the current state you have is going to be next state. And then, okay, I mean, the next state rather is going to be current state. And then you go ahead and do the iteration again until you reach convergence. And then, in line 35, you have run the weather forecast simulation. So you just have weather forecast convergence. See, so that's the function name actually here. So weather forecast convergence, okay? And then so you put the transition matrix, you put the initial state and the number of iterations you want, and things can keep moving like that. So if you run this in one blow, so what will take you, so if I was going to solve that mathematically, right, I could do it for an hour, before I can get these 20 iterations. But just by one click now, the result just jumps out in split seconds. So here you know, we have the iterations go. So when you do the first one, it's 0.8 and 0.2, which tallies with what we got when we're doing it manually. So the second one, we got 72%, 28%. The third one, we got 68.8, 0.688 and 0.312, which was also correct. So, and then so if you continue going, you'll discover that, this one started out with 0.8, now 0.2, 0.68, and it keeps going like that. You can see it's converging towards a particular value. So you see, if you take it to four decimal places, like, okay, if we do four decimal places, in fact, we already have 67 here, 67 to here we have 6669. Here we have 6668. Here we have 6667. In fact, from the 10th iteration, to four decimal places, we keep having 667. So you see that at the end of the day, it looks like this sunny probability is going to be like 0.6667, while this other one will be 0.3333, like that. So that convergence. So depending on the number of iterations you want. So what if I change this to like 30 iterations? It can give error, right? But let's just see how that goes. Okay. So we still have something close. Maybe that won't work because here the iteration has been set to 20 already. So if we change this to 30, so maybe we can get even a better. I mean, the result is pretty much the same, nothing seriously different. Okay, pretty much the same, like that, pretty much the same. But of course, just like I told you, right, in this case, right, we had a case where we assumed that the probability that it's going to rain today is one. That is, you are sure 100%. So, but things don't always work like that. What if the probability that it's going to rain today is just is 0.7? That's 70%. But the probability that it is going to the probability that it's going to be sunny is 0.7, while the probability that it's going to rain is 0.3. That can change too. So if you run that now, interestingly, it's still the convergence is still about the same, although the behavior is a bit different now. So the only thing is that it now moves faster. No matter, so it means that with whatever initial condition you choose, it looks like the result is going to end up being like 0.6667 and 0.3333, like that. Of course, maybe the only thing that may change the result significantly is your transition matrix. So let's try with another kind of transition matrix. Say we have this, and the probability that it's going to rain is 0.65. The probability that it's going to be sunny is 0.65. Probability that it will rain is 0.35. While the probability sunny to sunny is 0.65. Probability sunny to rainy is 0.65. Probability rainy to sunny is now like, say, 0.25. And the probability rainy to sunny is 0.75. okay, maybe that's going to have some significant impact. So you can see the values are not the 0.667 thing we are doing. So your transition matrix and all that is going to have a lot of effect on the results you get. So you can see that if you're working with Markov chains, the result tend to stabilize after some iterations. So that is just what I feel I should demonstrate in this video. And I know that has been very helpful for you. So be sure to subscribe to my channel so you can learn like this. You can learn math, you can learn coding in Python, you can learn all kinds of things. There's so much to learn. I have a lot of playlists on different topics like set theory, probability, matrices, um, basic calculus, vectors and all of that. So you want to, of course, I also have a playlist on scientific computing, which I'm building. So you want to avail yourself of this opportunity. The interesting thing about my scientific computing videos is that you can also download the Jupyter notebooks I'm using and implement them and iterate them and see how the things are working. So that's one way I've discovered is very good to learn coding. So be sure to subscribe to my channel, hit the notification bell also, so you can always get alerted when a new video is released. And don't forget to comment, like, and share. Till I see you again, have a nice time. Bye.